Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same module, that is a database design concept, but the new chapter, that is the chapter number 4, and we have started with the chapter number 4 in the last class, but we have covered two small topics, that is or two or three topics that is available in chapter number 4. Now I'm going to continue number 4 and we have finished with the chapter number 3 in the last class, also continue with the chapter number 4. So let's start with the previous class session, or the previous class, we can say the theory that we have covered in the last class. So let's start with the session with the previous class session. In the previous class we have started with the topic, we have started with the concept, that is the modifications of the database, that is how to do the modifications in the database, or how to modify the database, that is how to modify the structure of the database, or the elements of the database, that is the modifications of the database. So we have restricted our attention until now to the extraction of information from the database. That is how to extract the data from the database, not how to modify the data. That is, extraction is only possible with the help of the database. Now next is there is a concept that is available, that is how to modify the data in the database, that is a modification of the database. So first of all, the first part is modification is the deletion. Deletion means how to delete the database, or how to delete the various rows or the column that is available in the database. That is a modification. First modification is the deletion. That is how to delete the data. That is what are the various method to delete the data. That is a deletion. So a delete request can be forward, or we can delete only those tuple or whole tuples. We cannot delete values on any particular attribute. That is, there is no this modification does not involve modifications or delete the values on any particular attribute, but we can delete the entire row, entire column, or we can say the entire table. So this is delete from R, where P represents a condition and the R represents a relation. These are the various examples. So delete from the instructor, where department name equals to finance. So delete all the rows in an instructor relation pertaining to the instructors in the in finance department that is available. So these are the various we can say the examples. Then we discuss about the insertion, that is how to insert the data, or how to insert the not data, how to insert the table. That is also a modification part. How to insert the tuple, how to insert a we can say the whole tuple, that is the insert into course. What are the values that is given? This is the syntax that is given. When the next one is updates, that is the next part, that is how to update the database, how to we can say the update the database to the scope of requirement, to the scope of value, that is the update. So in certain situations we may wish to change a value in a tuple without changing all values in the tuple. For this purpose, the update information or the update statement can be used. So as we could use for the insert or delete, we can also use the update. So there is the update, that is if there is a changes in the salary, that is the salary will be hike, or the all the employees salary will be hiked by the 5%. That is done by the update information, that is the update instructor set salary, that is equals to the salary into 1.05. So update the table or update the relation, that is the instructor relation, and set the value of the salary to the salary into 1.05. The preceding update statement is applied only to the ones of the tuples in the instructor relation. If a salary increase is to be paid only to the instructors with a salary of less than 70,000, we can write this is update instructor set salary equals to salary into 1.05, where salary is greater than the or less than the 70,000. This is a condition, that is salary is less than 70,000. That is a condition that is given. In general, the where clause of the update statement may contain any construct legal in the where clause or the where clause of the select statement, that is including the nested statement. So this is the information, examples of the update information. Then we have discussed about the summary, that is the summary of this chapter, that is the winding of this chapter. Then various questions that is available in this chapter. Then we move forward to the chapter number 4, that is the next chapter, that is the intermediate SQL, that is how to use the intermediate SQL, that is the intermediate of the SQL. So in this chapter we continue our studies of the or our study of the SQL, that is the intermediate SQL, that is the middle level of the SQL, that is what are the various forms of the SQL. So we have studied about the introduction to the SQL in the third chapter. Now next is the intermediate SQL. That is not the high level SQL, not the low level SQL, not the introduction, but the intermediate level of the SQL. That is how to use the intermediate level of the SQL. The first part that is available is the join expression. That is how to join the values, how to join the relations, how to join the tuples. So in section 3.3.3 we introduce the natural join operation. So we have already studied in chapter number 3 how to join the relations. That is done by the natural join operation. SQL provides other forms of join operation also, and that includes the ability to specify an explicit join predicate. That is how to join the predicates and how to use the predicate that is available, and the ability to include in the result tuple that are excluded by the natural join. That is how to use the natural join that is excluded by the natural join. The examples in this section involves two relations. There are two relations, that is there are two tables that is involved. One is the student table, one is the text table. This is the student table and this is the text table. Next one is text table. That is student take the admission in the various courses. Then how to join by using the join operation, by using the join keyword. So this is select star from student. The join takes, that is the student table will be joined with the takes on student id dot takes id. So select the all the fields, all the attributes of the table from the table student that join with the takes on the student dot id equals to takes dot id. The on condition above specifies that a tuple from student matches a tuple from takes if their id values are equal. So if their id's values are equal, they are matching with each other id values, then the condition will be satisfied. Then that gives the tuples from the table that matches a table or tuple from the takes. That will be done by the natural join. So this is select asterisk, that is selecting all the attributes from the student and the takes where the student dot id equals to takes dot id. That is the student dot id that is equals to the takes dot id. This is the next we can say the next query that is used, that is a select student id as the id. So the id of the student has names has been changed as an id, and also select the name, also select the department name, total credit, course id, section id, semester, year, grade from the student table that joins with the text table, because some relevant information is available in the student table, some information is available in the text table. So this joins the two tables, and how they are joining by using the id. So there is a student dot id equals to text dot id. Then there is outer joins also. We can also use the outer join. Suppose we wish to display a list of all students displaying their IDs and names, department name and total credit along with the courses that they have taken. So the SQL query that appeared to retrieve the required information is select X from student that natural joins takes. So this the student and the join, or the student and the text table are joined on the student ID and the text ID with second occurrence of the ID omitted. That is, they are providing only the we can say the unique result that is available in the table. And there are three types of outer join that we have studied. That is the left outer join, right outer join, and the full outer join. These are the various example and join types and the various conditions. Now next is the views. That is today's topic, that is how to use the views, or what are the different views that is available in the SQL. So in our example up to this point we have operated at the logical model level. Now till now we are operating on the logical model, that is a logical schema, that is a relational schema. That is, we assume that the relations in the collection we are giving are the actual relations stored in the database. Now we have assumed that the relations, that the tables that is used in the collection we are given are the actual relation that is stored in the database. That is the assumption we have taken. That is a logical design. It is not desirable for all the users to see the entire logical model. There are some security considerations, security checks that will be available, so the data is not available or data is hidden from the user. Consider a clerk who need to know an instructor's ID, name and the department name, but does not have authorization to see the instructor's salary amount. This person should see a relation described in SQL. So how to use the authorization, how to use the instructor salary amount. That can be done. This person should see a relation that is done by the select ID, name, department name. So select the ID attribute, name and the department name attribute from the table instructor. Aside from the security concern, we may wish to create a personalized collection of the relations that is better matched to a certain user's intuition, that is a logical model. So next part is that we may want to have a list of all the courses that is offered by the physics department in the fall 2009 semester with the building and the room number of each section. The result that we have created for obtaining such list is, this is the result, that is select course ID, section ID, building, room number from the course table and the section table. There are two tables that is used, where course ID equal to the section course ID. That is, there is a common field, that is a unique field that is available in both the tables, that is a course ID in the section table as well as the course table. And course.department name equals to physics, and the section.semester equals to false, and the section.year equals to 2009. So in this we are using the two tables, that is a course and the section. Some part or some attributes are taken from the course table and some part or attributes are taken from the section table. So it is possible to compute and store the results of the above queries and makes the stored relation available to the user. However, if we do so and the underlying data in the relation instructor course or the section changes, the stored query results would then no longer matches the result of the re-executing the query on the relation. In general, it is a bad idea to compute and store query results such as those in the above example. So instead, we are using a virtual relation that is defined by the query, and the relation conceptually contains the result of the query. The virtual relation is not pre-computed and stored. That is, a virtual relation that we have taken is not pre-computed and stored, but instead it is computed by executing the query whenever the virtual relation is used. And such a relation that is not a part of the logical model, that is made visible to a user as a virtual relation. So this is not the logical relation that is some security features are applied, no, but this is visible to the user as a virtual relation that is known as a view. So there are some virtual relation that is done or that is shown by the view. It is also possible to support a large number of views on the top of any given set of actual relations. Now, first is view definition. That is, what is the view definition and how the view definition will be used. So we define a view in SQL by using the create view command. So if I want to create a view, if I want to create the virtual relation or the virtual view, that can be done by using the command, by using the, we can say, the attribute, that is a create view command. To define a view, we must give the view a name and must state the query that computes the view. So to define the view, we must give how to view a name and how to state the query that computes the view. The form of the create view command is, so what is the form, what is the syntax? That is a create view v as a query expression, where query expression is any legal query expression. The view name is represented by the v. That is, the name of the view is v, and the query expression is any query that is available, like select star from employees, select star from table, anything that is available. Consider again the clerk who needs to access all data in the instructor relation except salary. The clerk should not be authorized to access the instructor relation. Instead, a view relation faculty can be made available to the clerk with the view defined as follows. So this is defined the views, that is create a view faculty as, what is the ID, what is the, we can say, the query that is used as select ID, name, department from the instructor. So this consider the clerk who needs to access all the data in the instructor relation. So this is all the data that is available in the instructor relation except the salary. The clerk should not be authorized to access the instructor relation. So instead, a view relation faculty can be made available to the clerk. So a clerk can view the or can change the or can take the relation as a faculty, that is taking the view or seeing the view as a faculty that contains various information from the table instructor. So the view relation conceptually contains the tuples in the query result, but is not pre-computed and stored. Instead, the database system stores the query expression associated with the view relation. Whenever the view relation is accessed, so whenever we are viewing the result or view relation is accessed, its tuples are created by computing the query results. That is, its tuples, its rows are computed or created by computing the query result. Therefore, the view relation is created whenever needed on demand. So, whenever we are creating the views, that is, the view relation is created whenever there is a demand, or needed a demand. To create a view that lists all the courses or all course section offered by the physics department in the fall 2009 semester with the building and the room number of each section, we write. So, if I want to create a view that lists all the course sections that is offered by the physics department in the fall 2009 semester with the building and the room number of each section, then we write create view physics fall 2009, that is create the view that is the physics fall 2009 as select course id section section id building room number from two tables or the from two relations, that is the course and the section. So one of the first of all, the name of the view is physics fall 2009, and what is the query that is used, what is the data that is fetched, what are the attributes, that is a course id, section id, building, room number from two tables, that is the course and the section table, where the course.course id equals to the section.section or section.course id. That is the course id is a common field that is available. So taking the two rows, that is the course and the section, and taking the course id from the or matching the course id from the two tables. And course dot department name equals to physics, and the section dot semester equals to fall, and the section dot year equals to 2009. So taking the department name from the course table, and taking the semester from the section table, and taking the year also from the section table. So department name is physics, semester is fall, and the year is 2009. And taking the different attributes from the tables, that is the course id, section id, building, room number. Now, next topic is how to use the views in query language or SQL queries. That is how to use the various views in the SQL queries. So this is select course ID from the physics fall 2009. So select the attribute, select the column that is a course ID from the view that is a physics fall 2009 where building equals to Watson. So what is the building name? That is a Watson. So view names may appear in a query any place where a relation may appear. So this gives the argument, or this gives the relation, or this gives the Watson building by the writing or by writing this one. View names may appear in a query any place this is done. The attribute name of a view can be specified explicitly as follows. So what are the attribute name that is given? That is the attributes name of a view can be specified explicitly as follows. So this is create view department's total salary. So again one more view is created, that is the department total salary, and there are two fields that is taken, that is the department name and the total salary as. What is the query that is given? That is a select department name comma sum salary, that is finding the sum of or addition of all the salaries, that is a sum salary from the table instructor, that is grouped by the department name, that is grouped by the department name, that is what is the name of the or how to do the grouping or what is the criteria for grouping, that is grouped by the department name. So multiple department, that is for example computer science department, for example finance department, physics department, that is grouped together. For example, if there are three computer science department, that is grouped together into one. If there are three physics department, that is grouped together into one. So that is grouped by the department name. So what is the name of the view? That is the department total salary. And what is the query that is used? That is the department name sum salary from the instructor, that is grouped by the department name. The preceding view gives for each department the sum of all the salaries of all the instructors at that department. Since the expression sum salary does not have a name, the attribute name is specified explicitly in the view definition. For example, we can define a view physics for 2009 Watson that lists the course ID and the room number of all physics courses that is offered in the fall 2009 semester in the Watson building. That is a create view physics fall 2009 Watson as. So what is the name of the view that is created? That is a physics fall 2009 Watson as. Again taking the query, again fetching the query, again applying the query, that is a select course ID and the room number from the physics fall 2009. So what is the relation or what is the table that is view? That is a physics fall 2009 where building equals to Watson. Now taking the view or taking or fetching the query, fetching the output from the query, that is the physics fall 2009, which is again the view, not the full relation, but the view that is available, that is created from the relation. Now how to materialize the views? So certain database systems also allow view relation to be stored, but they make sure that if the actual relations used in the view definition change, the view is kept up to date. Such views are known as materialized construct or materialized view. So that how to view the relations, or some databases also allow the relation to be stored, but they make sure that if the actual relation used in the view definition change, the view is kept up to date. For example, I've created one table that is employee. I modify some attributes in the employee table, and I've created one view of that table. For example, employee underscore fall. If the view or the database changes, then there is a information that is updated in the view. For example, if I change the value, if I change the salary of one employee from the 10,000 to the 20,000, that information must be updated automatically by the database or by the SQL language using the or by the SQL language in the view definition, that is known as materialized views. That is the main concept. This is the same example that is given. For example, consider the view department total salary. If the above view is materialized, its result will be stored in the database. However, if an instructor tuple is added or deleted from the instructor relation, the result of that query defines the view would change, and as a result, the materialized view content must be updated. The process of keeping the materialized view up to date is known as materialized view maintenance. So whenever I want to create, or whenever I want to process, that is how to materialize the view up to date, that is done by the materialized view maintenance. View maintenance can be done immediately when any of the relations on which the view is defined is updated. Now how to update the view? That is the next part, that is updation of a view. That is how to update the views, or how to update the information in the views. So although views are a useful tool for queries, they present serious problems if we express updates, insertion, deletion with them. Now what is the difficulty that is available? That is a modification to the database that is expressed, that is defined in the terms of view, must define in modification in the actual relation in the logical model of the view. So although the database, or although that views are a different part or are a useful part of query, the main reason is that there must be updation of the view. That is, if there is any changes in the table, that tables must be represented in a view. So updation of the view is very, we can say, the serious problem that is available. So we express updates, insertion, deletion with them. The difficulty is that a modification to the database expressed in terms of a view must be translated into a modification to the actual relation in the logical model of the database. Suppose the view faculty, which we saw earlier, is made available to a clerk. Since we allow a view name to appear whenever a relation name is allowed, the clerk can write. So suppose we allow a view name that is to be appear wherever a relation name is allowed. So the clerk can write insert into faculty. That is the insertion will be made, that is insert into the faculty, that is the faculty view. What are the values that is given? That is 30765 green and the music. This insertion must be presented by insertion into the relation instructor, since the instructor is the actual relation from which the database system constructs the view faculty. Now this is the same line, that is how to update the view, or how to update the information into the relation. So if I want to insert anything in the relation instructor, so I can use the, or I can use the instructor table, or I can use the faculty view that is used. So since instructor is the actual relation from which the database system constructs the view faculty. So however, to insert a table into or tuple into an instructor, we must have some value for the salary. There are two accessible or reasonable approaches. First of all, reject the insertion and returns an error message. Insert a tuple into the instructor relation. Now, what is the another problem that is available that lists the view in a different manner, that lists the view in the university. So in general, a SQL view is said to be updatable. That is a there is a updation of the various view. That is there is a updation of the SQL view that is available. That is inserts, updates, or delete can be applied on the view. The following conditions are all satisfied by the query defining the view. The from clause has only one database relation. The select clause contains only attribute name of the relation and does not have an expression. So there is a from clause, there is a select clause, and there is a clause that is not listed in select clause can be set to a null clause. And the query that does not have a group by or having clause. Now next is the transactions. That is what is the transactions or how to work with the transaction. That is a part of the intermediate SQL. So we have covered with the join expressions, we have covered with the views. Now next part is transactions. So let's take a break right now. Then after the break, move to this topic, that is a transactions. Let's take a break right now. So come back from the break. Now let's start the session again. So let's start the next topic, or let's start with the next topic, that is the transaction. That is what is the transaction, how to use the transaction, what are the various transactions that is available in the database. So a transaction consists of a single query or updates of the query or updates information. So a transaction, when we talk about the transaction, that consists of a sequence of a query. That is a what is the sequence of query, how to maintain the query, that consists of a sequence of query or the update statement. The SQL standard specifies that a transaction begins implicitly when an SQL statement is executed. So the SQL standard specifies that a transaction begins implicitly when a SQL statement is executed. So whenever I execute any query, any SQL statement that is available, that is a transaction begins. So transaction consists of a sequence of query or the update statement. One of the following SQL statement must end the transaction. So one of the SQL statement must end with the transaction. What is the end that is available with the transaction? That is the first is the commit work. That is commits the current transaction. That is it makes the update performed by a transaction become permanent in the database. That is a commit work that commits the current transaction. That is this is a commitment that is available. That is it makes the update performed by the transaction become permanent in the database. After the transaction is committed, a new transaction is automatically started. So once the transaction is committed, that is we have committed the transaction, then automatically a new transaction is automatically started. Then next is the rollback work. That is a rollback work means that causes the current transaction to be rolled back. That is it undergoes all the updates that is performed by a SQL statement in the transaction. That is a rollback that causes the current transaction to be rolled back. That is the same transaction to be rolled back again. That is it undoes all the updates. That is whatever the update that is available, that is undone. That is a again make changes to the same transaction. Again the following updates are not perform well. That is undoes. That is a undo the same operation, undo the same update that is available, that is performed by an SQL statement in the transaction. Therefore, the database state is restored to what it was before the first statement of the transaction was executed. So commit means the final work has been done, and the rollback work means the work will be repeated again and again. That is the rollback work. So the keyword work is optional in both the statements. So there is no mandatory to use the keyword work, but we have to use either the commit and the rollback statement or the rollback condition. The keyword work is optional. Transaction rollback is useful because if some error is detected during the execution of a transaction, so if there is any error, so we can roll back the transaction, we can roll back the whole transaction so that it will go to the or it will quit the edit session without changing the without making the any changes. So this is like a without changes the condition, that is how to make the conditions or without changes any conditions, right? Yes, Joseph, tell me the question. What's your question? Yes, Joseph, from the assignment, tell me the question. What's your error? What's your, we can say, the doubts? Hello, Joseph. Yeah, Joseph. Tell me the. Yes, Joseph. Are you able to hear me? Yes, Joseph. Tell me. Yes. Time duration is from the 31st March to the 1st April. Till 1st April or 1st April to 31st March. That is a financial year. 1st April to 31st March. 1st April to 31st March. It starts with the 1st April and ends with the 31st March of next year. Yeah, for example, if the financial year started in this year, that is the 1st April 2015, so it ends with the 31st March 2016. Yes, but it depends. If a question arises, it takes the time for the 2 years, then 2 years. If the question says it is a time for the 1 year, then 1 year. Just a minute, I will open the assignment. You are talking about the procedural assignment, right? Yes, just a minute. I will open the assignment so that your concepts are clear very well. This is the question for the assignment. This says Nancy has recently has contacted this one, this one, this one. Date of interest. Yeah, this is a for the 1 year only. That is a for how to calculate the total interest for the 1 year. So time duration is a 1 year. It is said at the end of the financial year. That is means for the 1 year. Yes. No, no, no. Joseph, listen carefully. This is the C program. You don't have to calculate the total interest. You have to calculate the total interest based on the condition. This assignment will be fulfilled by using the if condition. If principal amount is greater than equal to 2000, then the rate of the interest is 20%. If principal amount is less than 8,000 or greater than 8,000 but less than 10,000, then the rate of the interest is 18,000. In the same way, if the principal amount is less than 8,000, then the rate of the interest is 16,000. So these are the three conditions. You have to only apply the conditions, only give the condition to the system. Then the system automatically calculates the interest. You don't have to calculate the interest, but only you have to give the conditions by using the if condition. There is a if, there is a else part. There is a if, there is a else part. So that can be done, or this can be done by using the C language. All right. Okay. Yes. Yeah, you can use the flowchart, you can use the pseudo code, any diagram, any model that can be used. All right. Yes. Yeah. Hmm. 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 Okay. Okay. Hmm. There is a line for the connection. Suppose we have chosen one C++ program for the files. For example, I've created one file that contains four fields: name, age, roll number, marks of a student, right? If I want to enter these records in the C++, that records will be detailed, or that records will be entered into a database. That is, that records will be go to the database. That is a ODBC. That is done by the ODBC. Now, how to use ODBC? There is a path, there is a connector that is available for the ODBC. That is how to use the C++ in the ODBC. That is ODBC equals to file name or the database name. Suppose my database name is sample.database. So I have to write ODBC equals to sample.database. So that will connect the C++ program to the database. Then if I enter the program, if I enter the details in the C++, that will be gone to the database automatically. On the ODBC. Yes, because we have to connect the database with the C++. So we have to give the name of the database from which we have to connect the database. Just try it with the use of, or use some we can say the some knowledge from the database from the internet, that is how to connect. And we can say the copy the path and paste into the your language, in your programming language. If there's any error, you can snapshot that error and you can send to me via email. All right. Okay, any other doubts? Okay, so shall I continue the session? Shall I continue the session? Okay. So next, let's continue the session. So there are two types of transactions. There are two types of SQL statement that will use that will end the transaction. One is the commit, one is the rollback. So there is a commit and there is a rollback. Commit means that commits the current transaction. That is, it makes the update performed by the transaction become permanent in the database. Uh, After the transaction is committed, a new transaction is automatically started. So one is the commit, one is the rollback. So whenever we use the commit, that means a commit transaction is committed and the new transaction is automatically started up. That is done by the commit. And then rollback, that causes the current transaction to be rolled back. That is, the same work have to be rolled back. The changes that we applied have not been made permanent. That will be rolled back again. That is a rollback condition. There are two types. One is a commit and the rollback. By either committing the actions of a transactions after all its steps are completed, or rolling back all its action in the case the transaction could not complete all its actions successfully. The database provides an abstraction of an data transaction as being atomic, that is indivisible, that is done by the atomic. Then next is the integrity constraint, that is how to use the integrity constraints, or what is the integrity constraint that is available, that is done by the transaction, that is the transaction methods. So integrity constraints ensure that changes made to the database by authorized users do not result in a loss of the data consistency. So whenever we use the integrity constraints that ensure that changes made to the database by authorized users do not result in a loss of the data consistency. That is, if there is any changes that is made to the database by the authorized user, that does not result in a loss of the data inconsistency or the data consistency. Therefore, integrity constraint guard against the accidental damage to the database. Examples of integrity constraints are, so what are the examples that is available? So first of all, the name cannot be a null. No two instructors can have the same instructor name. That is the integrity constraints. That means any changes that is made to the database by authorized user does not result in a loss of the data consistency. So if there is any changes, that means the consistency of the database must be maintained. Now, what are the various examples? uh, that is how to ensure the database consistency. That is, first one is an instructor name cannot be a null. That is, a name that is given of the instructor cannot be a null value. Then next part says no two instructors can have the same instructor ID. That is, the instructor ID is unique for the different instructor. That is, no two instructors can have the same email instructor ID. Then every department name in the course relation must have a matching department in the department relation. That is, every department that is available in the course relation must have the same. So these are the various integrity constraints. Then budget of a department must be a greater than the dollar. That is a $0. That means the integrity constraints. I'm just coming within 2 minutes. So these are the four rules, or these are the four examples of integrity constraint. That is how to maintain the consistency among the data consistency among the database. Now, how to maintain the consistency, or what is the constraint that is available on a single relation? So there are constraints that is available on the single relation. So we describe in section 3.2 how to define the table using the create table command. The create table command may also include the integrity constraint statement. That is, whenever we use the create table command, that includes the integrity constraint statements. In addition to the primary key constraint, there are a number of other ones that can be included in the create table command. So we have used the create table command, and we have used the, or we can also apply the primary key constraint that is available on the single relation. Then next is the not null. That is, the allowed integrity constraint must include the not null, unique, and the check. So not null means that the value is not null, and the unique value and the check means the examples, or the, we can say, the condition that will be applied. So we cover each of these types of constraints in the following sections. Now next constraint is the not null constraint. That is, a not null constraint is available. That is, there is no null value, or the not null value that is available. That is a not null constraint. So the null value is a member of all the domains, and as a result is a legal value of every attribute in the SQL by default. That is a not null constraint. For certain attributes, however, null values may be inappropriate. Consider a tuple in the student relation where name is null. That is, the name that is available is the null value that is available. So that is also a constraint, that is a not null constraint. So we have applied, or we have to apply it, or we use the not null constraint, that the value is not null. Suppose if I am giving that the name of the student, name of the instructor is not null, that is done by the not null constraint. This is the name, then varchar 20, that is not null, then budget, then numeric 12 2, then there is a not null. The not null specification prohibits the insertion of a null value for the attributes. Any database modification that would cause a null to be inserted in an attribute declared to be not null generates an error diagnostic. There are many situations where we want to avoid null values. So there are many conditions where we want to avoid the null values. For example, of the primary key, when we use the primary key, we are not using the null values of the relation schema. That is, there is no null value in the relation schema. For example, in our university example, the department relation, if the attribute department name is declared as a primary key, so it does not take the null value. So whenever we use the primary key, so there is no null value, or the no null value that would be allowed. So we can specify, or we can give, or we can specify them by using the not null attribute, by using the not null constraint. So one constraint is that is how to apply the constraints, that is on a single relation, that then not null constraint, then unique constraint. So the SQL also supports an integrity constraint, that is a unique AJI, AJ2 till AJM. So the unique specification says that the attribute forms a candidate key, that is no tuples in the relation will be used, or can be equal on all the listed relations. However, the candidate key attributes are permitted to be null values unless they have explicitly have been declared to be not null. Recall that a null value does not equal any other value, that is, does not use any values. That is a unique constraint. Then next is the check clause, that is how to use the check clause. That is the next constraint that is available. So we can also use the check clause to ensure that the attribute value satisfies a specified condition. That is, if there is a specified condition that is used, so we can use the check value or the check clause to ensure the attribute name, to ensure the attribute value that satisfies the exact requirement. So we can use the check clause to ensure that the attribute values satisfy the specified conditions. So for example, a clause that is a budget is greater than 0 in the create table command for the relation department would ensure that the value of the budget is non-negative. That the value that is available for the budget is a non-negative value. So this is the one of the example, that is a create table section, that is a create a table section. Then what are the various, we can say, what are the various fields. One is the course ID, that is of varchar. One is a section ID, that is of varchar. One is a semester, that is of varchar. Then year, that is of numeric. Then building, that is of varchar. Then room number, varchar. Time slot ID, varchar. These are the various fields that is available. Then there is a primary key, that is a course ID, section ID, semester, year. Then how to check, that is how to check the semester, that is in the fall, winter, spring or the summer season. So we can use a check clause to simulate an enumerated type by specifying that the semester must be of the fall, winter, spring or the summer season. Now next is the referential integrity, that is one of the important concepts, that is how to use the referential integrity. So suppose we wish to ensure that a value that appears in one relation for a given set of attributes also appear for a certain set of attributes. So if a value that is given in one relation, that is given in one table for a given set of attributes, also appears for a certain set of attributes for a given set of attributes in another relation. So there is a, we can say, the consistency, we can say the comparison between two relations, that is one that appears in one relation, a value that also appears in the other set of relations, other set of attributes and relation, that is known as the referential integrity. So foreign key can also be specified as a part of the SQL table. So foreign key is also using the referential integrity. This is one of the best example, that is how to use the referential integrity. This is foreign key department reference the department, that is this references the department on the integrity constraints. Then how to use the complex check condition by using the check, that is a time slot ID in the select statement that is used. Then there is an assertion, that is also a condition that expresses a condition or that gives a condition that we wish to database always to satisfy, that is the assertion. Now next is the database or SQL data types and the schema, that is what are the various data types that is available in the SQL and what is the logical design, that is what is the schema of the database or SQL schema. So this I'm going to start not right now, that I'm going to start in the tomorrow's class. So that's all for today's session. I have to wind up this class over here only because this is a too lengthy topic, or this is very interesting topic, very important topic. So we will take this topic in the next class. So that's all for today's session. Thank you so much everyone for listening me. And if there is any doubt, any suggestions, any advice, any query, then you can ask from me. So thanks a lot everyone. Bye bye everyone.